All right, so in this video we are going to look at absolute value inequalities. This will be our last video on inequalities. Um, and absolute value does some interesting things when it comes to inequalities. So we have to take a look at this. Let's go do that now. So this just means inequalities that involve the absolute value symbol. So first, let's talk about what absolute value means. So if I take absolute value of x, what is that denoting? What does that mean? Well, that just means the distance x is from 0. So this is the distance x is from 0. Okay? And so on the number line, if I take, come on up here, number line. If I take a number x, say x is 2, right? That's not what I want to do. Okay, so if I take a number like okay, so if I take a number like -2, okay, and I want to know what the absolute value is, well, I just measure how far it is from 0, right? How far is 2 from 0? Well, it's 1, 2 spaces away from 0. So that's why the absolute value of -2 is equal to 2, right? And so, yeah, a lot of times we think about this as just stripping off the negative, right? So if the number was negative, it becomes positive. And so essentially that's all it's doing. But geometrically, it's nice to think about it this way, that it's actually just measuring the distance to 0. And this will be an important way to think about it when we start dealing with some inequalities that get a little more complicated. Okay, so let's look at an inequality involving an absolute value. Let's take a very simple one here. Let's look at the inequality that is the absolute value of x is less than 3. Okay, so let's give ourselves a number line here. And what does this mean? Well, it means that the distance from x to 0 is less than 3. So what we're thinking about is all numbers that are within 3 units of 0. So we'll shade in all of these up to here. If I go past 3, I'm more than 3 units from 0. And I can go down to here. If I shade past -3, I am more than 3 units from 0. So I can only shade in between there and there. Now, because it's strictly less than, I cannot include these endpoints, so I leave open circles. Okay, so that's how I would write that, graph it as on the number line. How would I write it as an inequality? Well, just looking at the picture there, I think I can see that the inequality is -3 is less than x is less than 3. It's a compound inequality, and so we know that this becomes this. And so you can think of this absolute value inequality as a compound inequality. Now, what if I wrote less than or equal to here? Well, then what would happen is that I would be shading in these numbers because these are 3 units away from 0. And so I get less than or equal to signs here. Okay? So what about writing an inequality sign in the other direction? What happens then? All right, so let's take a look. All right, so my inequality will be absolute value of x is greater than 2. Let's see what happens here. So we're saying the distance from x to 0 is greater than 2. So x is more than 2 units away from 0. So it's out here. Oops, why aren't you letting me draw? It's out here. Or more than 2 units from 0, it could also be out here. Now, if it's more, that means it does not include these points here, because it's got to be strictly more than. Can't be exactly 2, it's got to be more than 2. So I get this. So how would I write this as an inequality? Well, I have to use a compound inequality. We see that on the one hand, on the left-hand side, over here, x is less than negative 2. And on the right-hand side, over here, we see that x is greater than 2. Now, when the two intervals are disjoint like this, when we have two disjoint intervals, what do we write in between? We write or. So this is how I would write the inequality. So notice the difference here. This is something you want to be able to do on your own. If it's a less than or equal to with an inequality, I get a compound inequality with an and, right? And so I can write my inequality as follows, and I get an interval that goes between two numbers. If it's a greater than or equal to, I get a set of inequalities with an or in between, and I get two disjoint intervals. Now, there's one other possibility here. What if I said x was, let's say absolute value of x is less than negative 4. So this is saying the distance from x to 0 is less than negative 4. Well, wait a minute, how can this be? Distances are always positive, right? You can't have a negative distance. So in this case, there's nothing to graph. There are no x's that satisfy this. There are no x's that are less than negative 4 units away from anything, right? It's not possible. So there actually is no solution here. There's nothing to graph. And I lied. There's one other possibility. It just occurred to me. What if we did something like this? What if we said absolute value of x is greater than negative 4? Well, the distance from x to 0 is greater than negative 4. Every x satisfies that, right? Because all distances are non-negative, right? So it's guaranteed that they're greater than negative 4. So actually in this one, we would have everything is included. Every single x in existence, the distance is greater than negative 4. Because the distance to 0 is always positive, and any positive number is greater than negative 4, right? So this actually includes everything. So as an inequality, what would I write? Well, I would just say that x it's a single interval, so I know I can write it as an inequality like this, a compound inequality in this form. And it goes all the way out to infinity and all the way back to negative infinity. So actually I would write it like this. So every single real number works. Okay? Now, we can mix things up a little bit. We can take our inequalities and start putting, instead of just x in there, we can put some other stuff. So what if I wrote something like this? X minus 2 is less than 3. What would we do here? Well, this is saying, well, there's a couple ways to think about it. But I think the easiest way to do it is just go back up and see what we did here. Okay? When we had an absolute value and less than a number, what happened? It became this compound inequality. And so that's what's going to happen here, right? Just do the same thing this arrow is illustrating. Go from the absolute value to the compound inequality. So that's what we'll do. So what's the compound inequality? Well, we put the -3 is less than the thing inside the absolute value is less than 3. So this is the same arrow we had before, right? It's just sandwiching that thing between -3 and +3, just like we did before. And so we have a compound inequality we can solve. And so you can actually solve this inequality. You can add 2 across. And what happens? -3 plus 2 is -1. It actually becomes this. Let's graph this and see what this looks like. Okay, so x goes from -1 up to 5, and it's everything in between. Now, graphically, see if you can see what's going on here. Relate that to the inequality that we started with, right? If x minus 2 is less than 3, see if you can see an easy way to picture that according to the graph that we made. Right? So if you look, 2 is right here. That's the 2, right? And so what we're looking at is all the points that are within 3 units of 2. So that's another way to think about that. If I have an inequality, they're having a party outside my window. I don't know if you can hear that. We'll spice up our video. So if I have the inequality x minus some number is less than some other number, what that means is it's the set of numbers that are less than b units away from a. Right? This is all numbers that are less than b units from a. So on the number line, if a was here, I would just go b units to the right and b units to the left, and that would be my interval. Okay? And that's exactly what we did up here. We went 3 units to the right and 3 units to the left, and that gave us our interval. Okay, there's one other thing to look at, and that is when we put the greater than sign, or greater than or equal to. Let's make it greater than or equal to, just to mix things up, okay? Not a huge difference. So let's do absolute value of x minus, let's just do 1, is greater than or equal to 4, okay? What would happen here? So well, do the same thing we did before, turn it into a compound. Well, we'll turn it into a compound inequality, but let's see how that happens. When we had a greater than, what was the situation? What happened? Aha, here it is. We got it, when we had a greater than, we got an or. So look at this. We got x is less than negative the number, or x is greater than positive the number. So x is the thing inside the absolute value. So let's do that over here. Okay. So what we're going to do is we're going to say x minus 1 is less than the negative of the number, or x minus 1 is greater than the positive of the number, right? And now we had equal to here, so I should have left it like that. This is just completely analogous to what we did above. So rewind the video, take a look at that if it looks a little confusing. See if you can match those up, okay? And so this thing here is just what was inside the absolute value, just like we did before. So if you just look at what was circled up above in the example, that was just an x. But here it's an x minus 1. It's the same idea, all right? So we have to solve these two inequalities. So what do? Well, in this one, I'd add 1 to both sides. And in this one, I'd add 1 to both sides. Right, so what do we get? I get x is less than or equal to -3 over here. And what do I get here? I add 1 to both sides. I get x is greater than or equal to 5. Let's go ahead and graph this one. Okay. So x is less than or equal to -3. So I shade to the left of -3. And it's or equal to, so I fill that one in, right? Or x is greater than or equal to 5. So I go over to 5 and I shade to the right. And it's or equal to, so I fill it in. And so that's what it would look like as a graph. Okay? So just zoom out so you can see that thing in its entirety. Right? All right, so just to summarize what we were saying, let's go through a summary of things. So whenever you have absolute value of anything, could be just x or it could be an expression involving x, and that's less than a positive number a, then that means that this is going to give rise to the inequality -a is less than stuff. And let me move out of the way here. Is less than a. Okay, that gives that compound inequality. If you have absolute value of stuff is greater than a positive number a, then that's going to give rise to the following compound inequality. Stuff is less than -a, or stuff is greater than positive a. So notice the difference. The difference is whether we have a less than or a greater than. Okay, and that'll determine whether we get what kind of compound inequality we get. All right, and then the two other things that we looked at were the two, weird cases where we have stuff is greater than a negative number, right? And that just means everything's a solution because distances are always greater than negative numbers. So we just get this. And if we have, whoa, that's not what I meant to move. If we have stuff less than a negative number, then you have no solutions. Okay, because you can't have a distance that's less than a negative number. All distances are non-negative, right? So that's just a quick summary of the things that we talked about here. Okay? So there you are, so you can see it all together. So that's it for this video. I'll catch you on the next one.